Hello, my name is Mira Welner, and I'm a student at the University of California, Davis. Today, I'm going to be talking about research that I conducted at Carnegie Mellon University Image Science Labs with Professor Aswin Sankarankarayana. The research involves using unsupervised learning to determine the three primary materials found within a hyperspectral image. Hyperspectral images are often used to determine the primary materials found within a scene. The way this happens is the spectra found within the hyperspectral image are compared to spectra which are likely to be seen in the hyperspectral image. If one of the spectra matches, then that is indeed the material that's found within the image. The problem with this is that in order to do that, you have to have some idea of what materials are likely to be found within the image. If you don't have an idea, then you have to compare the hyperspectral image with spectra from many different sources, which can take a very long time. We solve this problem using unsupervised learning. We hypothesized that given a program that could take three primary spectra of a hyperspectral image and use them to derive the original hyperspectral image, you could also use convolutional neural networks, specifically autoencoders, to then go the other direction and take a hyperspectral image and from that derive the three primary spectra, which could then be used to determine the three primary materials of that image. Our unsupervised learning model uses a modified autoencoder. A standard autoencoder takes an image, compresses it using convolutional neural networks, and then decompresses it later using convolutional neural networks again. The original image should closely resemble the final image, and it's trained to do so. Our model is a little bit different because the decoder assumes that the compressed image represents the three primary spectra of the hyperspectral image. It then uses matrix manipulation to recreate the original hyperspectral image from those three primary spectra. It's then trained so that the final image closely resembles the original image. Because of that training, the compressor essentially becomes a machine learning model that takes the original hyperspectral image and compresses it into three primary spectra. While these preliminary results are very promising, further research must be conducted to ensure that this model is accurate. For one thing, it needs to be ensured that it can generalize on a variety of hyperspectral datasets. Right now, it's only been tested and trained on the Harvard Hyperspectral Real-World Image dataset. It needs to be prepared for any hyperspectral image that can be thrown its way. Therefore, it needs to be tested and trained on various other datasets that describe a variety of images, a variety of scenes, and have a variety of numbers of hyperspectral bands. Another step that must be taken is it needs to be ensured that the three spectra produced are similar to spectra likely to be actually found in the image. So for example, if a hyperspectral scene is of a scene that contains a lot of carbon, it must be ensured that at least one of the spectra is very similar to the carbon spectra. Hopefully, this preliminary study is able to pave the way for future research on using unsupervised learning to analyze hyperspectral images. Thank you.